Good morning, class. Today we are going to have another lecture of theory of machine, and today's topic which we are going to discuss, that is governor. So let's start with the introduction or the basic definition of governor. That what is the governor and what is its role and what are its uses and application. So starting with the definition, that is a governor regulates the mean speed of an engine when there are variation in a load. That means when there are abrupt changes in the amount of load, at that time government regulates the mean speed and controls that variation of load. In other words, we can also define this as the governor automatically controls the supply of working fluid to the engine with the varying load condition and keep the mean speed within certain limits. That means the governor controls the varying load condition or the engine speed while supplying the working fluid. That means it supplies the working fluid, and through that supply it controls the engine varying load condition and keeps the engine with a mean speed so that abrupt changes can be controlled in some way. So to better understand what is governor, let us take an practical or basic example. So taking that example. So now taking an basic example, that means when the load on an engine increases. Obviously we know that when a load on any object, let us suppose we are carrying a load of 5 kg, at that time our running speed or walking speed will definitely decrease, and we are unloaded, then our speed will vary. That means when we put a load on any object, at that point of time the speed of that object or body definitely decreases, and when that load is removed, at that point of time the speed automatically increases. Similar situation comes to an engine. So when the load on an engine increases, at that point of time its speed decreases. So therefore it becomes necessary to increase the supply of working fluid. On the other hand, when the load on the engine decreases, its speed increases, and thus less working is required, or rather we can say here less working fluid is required. So we can justify from this point is that when there is extra amount of load on an engine, at that point of time the speed automatically decreases. Hence, with the help of a container or extra amount of working fluid being supplied to the engine, we can control the speed. Hence, again on the second case, when the load on the engine decreases, its speed automatically increases. At that point of time, that extra amount of supplying of working fluid is being restricted. So that is the saving property. It is indirectly similar as flywheel. In flywheel, when there is extra requirement of energy, at that time flywheel is supposed to supply that energy, and when there is no requirement of extra amount of energy, at that time flywheel stores that energy. As similar to flywheel, governor plays similar role. It simply controls or restricts the amount of working fluid when there is no requirement. When there is less amount of load acting on the engine and when the speed is at nominal point. But when the engine load on the engine increases and the speed automatically decreases due to that point, at that time government supplies the extra amount of working fluid. So indirectly in one line we can say that governors controls the supply of working fluid, and hence through that it controls the mean speed of the engine, or it controls or it varies the mean speed of an engine. So obviously one point definitely will come into our mind, that how this supply of working fluid is being controlled. So all these supplies are controlled by the help of a throttle valve. So there is a valve being inputted in the arrangement of governor, where the throttle valve supplies when there is a requirement, and it automatically closes or restricts when there is no requirement of extra working fluid. So we will obviously look after the arrangement, how the throttle valve is being arranged, or how the other particles of the or other parts of the governor is being arranged in the later part. So now coming back to the types of governor, how governor is classified. So now coming to the classification of governor. So the governor is mainly classified into two types, that is first one is centrifugal governor and the second one is inertia governor. Now the centrifugal governor is classified into again two types. The first one is pendulum type and the second one is loaded type. Now pendulum type is classified into one type, that is watt governor, and the loaded type is classified into two types, that is deadweight governor and spring controlled governor. Again the deadweight governor is classified into again two types, that is one is Porter governor, another one is Proil governor. And the spring control governor is classified into four types, that is Hartnell governor, Hartung governor, Wilson Hartnell governor and Pickering governor. So these are the basic or overall classification of governor. So now coming to the topic, that is the terminologies which are being used in governors. So note down this classification of governors and then after we will go to the next topic. So now coming back to the next topic, that is terminologies used in governors. So I have drawn a basic diagram of a governor in which the upper end are shaft, the middle one the connector is known as spindle. These are the two fly balls. This is the slip which actually move to, up and down, and so that the flywheel arms are can reciprocate outward and inward. So the arms can rotate outwards and inwards, can move, and the sleeve can move reciprocately, that means up and down. Through that sleeves a ball clank lever is connected which can reciprocate to and fro motion, and in the downward portion of the sleeve a bevel gear is connected. So through that and through this ball clank lever a throttle valve is connected, through that the supply of working fluid is being controlled. So the throttle valve control the supply of working fluid, through that sleeve reciprocates or up and down, and through that the arms also move outward and inward, through that the flywheels control the main speed of an engine. So now coming back to the terminologies. So first one, that is height of governor. So what will be the height of the governor? Starting from that. So write down the definition first. So the first one is that is height of governor. It is mainly denoted by h. So what is height of governor? It is a vertical distance from the center of the ball to a point where the axis of the arms intersect on the spindle axis. So this is the spindle axis, this is the arm, this is the topmost point. So the height of the governor will be the vertical point, that will be the vertical height, the vertical point or pulley where the arms are being connected, and through that these fly balls, that the middle portion, that is the center of the flywheel. So from that top position to the center of the flywheel, the distance between this is known as height of the governor. Now coming to the second terminologies. So the second one is that is equilibrium speed. So it is the speed at which the governor balls, arm, etc. are in complete equilibrium and the slip does not tend to move upward and downwards. That means it is the mean speed, or other concept, it is the speed at which the all arm or spindle arm or fly balls, all these are come into equilibrium position, and that times the slave will neither move upward nor it will move downward. At this time the speed of the governor is known as equilibrium speed. So the third one is mean equilibrium speed. So the speed, it is the speed of the mean position of the balls or the slave. So the speed at which the balls or the slave come into equilibrium, at that point of time the speed will be mean equilibrium speed. So the fourth one is maximum and minimum equilibrium speed. So the speed at the maximum and minimum radius of rotation of the balls without tending to move either way are known as maximum and minimum equilibrium speed. So obviously we get through this definition that the speed at maximum and minimum radius of rotation. So what will be the radius of rotation? The distance of these links to the spindle is known as the radius of rotation. Here I denote it as by r. So small r denotes the radius of rotation. So the maximum and minimum radius of rotation at that point of time, the speed of the governor at maximum and minimum radius, so that will be provide the maximum and minimum equilibrium speed. So the speed at the maximum and minimum radius of rotation of the balls without tending to move either way, that means either this way, that means inwards or outward, it will not going to move either inward or outward. At that point of time, the equilibrium speed will be the maximum and minimum equilibrium speed. So the final point is slave lift. So what is slave lift? It is the vertical distance which the slave travels due to change in equilibrium speed. When there is certain change in the speed of equilibrium condition, at that time the slave, obviously I have already told you that the slave will reciprocate, that means it will move upward and downwards. So at that time the vertical distance which is being covered by the slave, when there is change in the equilibrium speed, that will be known as slave lift. I hope you all understand these 5 terminologies of governors. So thank you for the class.